All right, how about we get started here? So let's go on and take a look at number one. So here we have a system of equations, and we want to know when this system has no solution. So since this is a problem that is open-ended, I tend to not use Desmos for these. So what I'm going to do is get them both in standard form first. So this first one, I'm going to do 5x. And if I bring this 12y over, I'm going to get minus 24y equals 10. Now this one, I'm going to bring the py to the right side, right? So I'm going to do 5x minus py equals 13. All right, but I'm going to like flip the side. So 5x minus py equals 13. Now it's very easy to see. So we know that in standard form, there is no solution when the coefficients of x and the coefficients of y are the same, but the constants are different. So all we have to do is choose p to be 24, and then that scenario is going to work out. So p is simply just equal to 24. All right, let's move on to number two. This one can be a little tricky. I actually made kind of a mistake on this one when I was going over it like the first time. It's really important that we make this an inequality, not just a system of equations. I know sometimes we can just use equations instead, but I'm going to explain why we have to be careful. So if we look at we have this budget. So if I look at the money first, if I say flour, the amount of flour is X and the amount of sugar is Y, I have 3.8x plus 9.5y. And then I can't go over my budget. So I have a less than or equal to 1800. Again, it's natural to make that equals, but I want to explain why the inequality is super important. So then we have to buy at least 230 units. So that means the x plus the y has to be greater than or equal to 230. Okay. So now we're going to go to Desmos and kind of see what this looks like. So hop on into Desmos, and now we get 3.8x plus 9.5y is less than or equal to 1800. And then we have x plus y is greater than or equal to 230. When we do a little zooming out, we're going to go all the way up here. Okay. So now our intersection point is extremely important. Okay. We need a whole number. This one asked for sugar, and sugar was Y. So the Y value is 162.45. And notice that the double shaded region here, the green blue region, is below that. That shaded region is our solution region. So the highest value that Y can be is 162.45. And what happens is it's not rounding, it's truncating. We're getting rid of the decimal because we have to have a whole number of units of sugar. So then the answer is going to be 162. So the answer is 162. So if you got the intersection and just picked 162, that's fine. You would have gotten slightly lucky. Because imagine they asked for flour. Flour was X. Well, the whole region, the shaded region, is to the right of that X value. All right. It's below the Y value, but to the right of the X value, which means that 67.5, the least amount of flour that we would be able to have is 68. So it's kind of like it does matter a little bit that it's an inequality, right? So the range of amounts of flour that we could buy is from 68 and on, and every whole number after that, where the range of the amounts of sugar that we could get is 162 and then below, all the whole numbers below that. All right. So it is kind of important to think about that, because if we just did it kind of without the inequality, and they asked for flour, we might have given an answer of 67, thinking we wouldn't have the budget for that. But again, we got to see how kind of all of it plays out. So it is important that it's an inequality. So just to real quick, all we care about in this problem is the y being below 162.45. So we are going to just choose 162. So let's hop back to our problem and we are going to give an answer of 162. All right, let's move on. All right, on to number 3. So we have two equations, and we're going to add them together and want the x coordinate of the x-intercept. So you could definitely do this on Desmos. But I think let's just take a look at what it would look like if we didn't use Desmos. So obviously, if we use Desmos, we would just plug these in. We would basically just add these together and then like plug that in without having to actually add them together and just look for the x-intercept. But also, if you just add these together, 1/3 plus 2/3, that's just x. So basically, we're going to get like y equals, or r of x, but y equals x, and -8 plus 18 is 10. And the x-intercept is just when y is 0. So it's pretty easy to see that x is just -10. That's why I would always, if you want to use Desmos, it's not going to be a big deal. But some of these problems, you could easily just do them, and it really is not that hard. I also agree that typing that in is not really that difficult either. So either way, either you actually just put them added to each other and then look for the x coordinate, or just do it by hand. Okay, so we have a linear function. It wants the x-intercept of the graph. All right, so another x-intercept. But here, I am going to use Desmos because um, I don't want to have to take the time now. So in the last problem, it was really easy to add them together. But here, to actually come up with the equation, we have to find the slope and then, find either y-intercept or put it in point slope form and then do all that and then set y equal to 0. Rather than do that, I'm just going to use a Desmos table. So note, all right, so what I'm going to do is we know that it's linear. They tell us that here. We only need 2 points for a linear. So I'm just going to use those 2 points. So let me jump over to Desmos. And what you do is you add a table, and then I'm going to put those 2 points. So -7, 25, and then -6, 22. Hit this button over here to add regression. Linear regression is the default. Let's recenter this, and then just go right there. So another thing that I think is really important is when we're going to use Desmos a lot, if you can know like pretty much like fraction conversions. But let me just see, let me go back. So the answer is 1.3 repeating. It's helpful to know that that is 4/3. So let's go back to our here. Yeah. So it's helpful, and it's multiple choice. So, right. So we got 1.3 repeating. I think you'd be able to figure out that the answer would just have to be C. All right. Let's move on. So one, there's a couple different ways to do this. Um, the most direct way involves synthetic division, and that's not required for the SAT. So I'm not going to do it that way. If you know how to do it that way, then go for it. But since it's not a requirement, the way that or long division for that matter, but if you're going to choose between the two, you would choose synthetic. So I am going to show you a way where I think I'm just going to use Desmos. Trying to debate. No, I'm just going to pick a value. Okay, so one way, the Desmos way I can just describe, and you might like that better. You just put this in one of the like the first one and a graph is going to show up. And then you go to the second one and just put this answer. And if the graph is directly on top of it, you have the right answer. And if it's not, replace it with this one and so on. That is one way to do it. Okay. And that might be the best way. I'm just going to offer you another way. I'm going to choose my own value. I'm going to choose x to be 0. And when I plug in 0 to this expression, I get -7/4. And then I'm going to plug in 0 to each of these. So in this one, I get -2 minus 1/4, right? So all the x's just go to 0. Here I get -2 plus 1/4. Here I get -1 minus 2/4. And here I get -1 plus 2/4. And then I just kind of think, all right, -2 is -8/4 minus 1/4, not -7/4. -8/4 plus 1/4 is, but I want to double check something. -1, which is -4/4 minus 2/4, is not -7/4, and -4/4 plus 2/4 is not either. So we get the answer B. Right. So either way, unless the direct way to do it is again synthetic division, which is not required for the SAT, which is why I'm not doing it that way. What you can so either you can run through the answers that way, or you can just run through the answers on Desmos. Desmos is probably faster. I just like to offer everybody just like different ways of like looking at problems, and this could be helpful in some problems where you just pick your own value, get the answer, and the correct answer has to give you the same value. Sometimes a wrong answer can masquerade as a right answer just for that number. So that's why I did check all of them, just to be sure. Okay, on to number 6. So we have this equation where h is an integer. It has no real solutions. What's the smallest possible value of h? So first thing, I'm going to recognize that it's quadratic. So I'm going to multiply it out. So I'm going to get hx squared minus 42x, and I'm also going to add this 12 to the other side. So anytime I'm talking about the types of solutions to a quadratic, I'm going to think of the discriminant or Desmos. But I'm going to stay away from Desmos because it's open-ended. So I have b squared minus 4ac as the discriminant. And if there's no real solutions, I know that's less than 0 because that's what sits under the radical, and I can't take the square root of a negative and get real solutions. So I know this has to be true. So I'm going to actually do that. So b is -42. So I'm going to do -42 or 42 squared. And I'm going to get 1764 minus 4 times a times c. Well, a is h and c is 12. So I get minus 48h is less than 0. I'm just going to solve this inequality. So 1764 is less than 48h. Then I'm going to divide each side by 48. So I get 1764 divided by 48, and I get 36.75. So h has to be greater than that. So if h is an integer, the smallest that it'll be able to be is 37. So 37 is the answer. So that's why you can do Desmos, and yeah, you could keep messing with it, but I don't know. You probably if you're good at it and you get started right away and you start moving it and realizing that you want the parabola to have no x-intercepts, and you figure out which direction that is, and you kind of get there pretty quickly, you can do it. You certainly can. But again, just offering another way, the discriminant gets you there kind of more directly. Okay. Number 7. All right, so we have a function here. So what I'm going to do when I got a function like this, I am going to go right for the answer. Okay. So I am going to find the value of g of 6. So what I'm going to do is I'm going to plug 6 in. Okay, so I have a decision to make. This is a good problem. So I have 2g of something, x, equals g of 3 times that. One option is to plug 6 in here, okay? Because then naturally, right, I'll be solving for g of 6. But if I plug 6 in for this x, this will give me 18, but I don't have 18 on here. So I'm not going to do it that way. I am going to choose X to be 2. So I'm going to put that here. And if I put 2 here, the 2 times 3 is going to give me the 6. So it's just a little bit of critical thinking there. So now G of 2, I go to the table. G of 2 is 5. So I have 2 times 5 equals G of 6. So G of 6 is just 10. Okay, so you're presented with 2 different ways to get G of 6, and the one way wouldn't allow us to solve it because the value of G of 18 is not on the table. All right, number 8. The result of increasing the quantity X by 400% is 60. What's the value of X? All right. If I'm increasing something by 400%, I'm always starting at 100%, and I'm increasing it by 400%, which means I'm really taking 500% of it. So I'm multiplying it by 5. So I really get 5x equals 60. So x is simply just 12. All right. It's a lot of times it's easier to see, like if I was like a sales tax problem, like if I'm increasing something by 7%, I would naturally multiply by 1.07 because it's 100 plus 7%. But for some reason, when it's like hundreds of percents like this, like 400%, 500%, it gets a little tricky because I don't know. It's harder for our brain to like accept that if I'm increasing by 400%, I'm multiplying by 5. That seems kind of weird. But when you look at it as you're increasing, right, and it works. Because if I take 400% of 12, I get 48. And if I increase 12 by 48, I do get 60. So you can see that it does work. All right, we have a data set, 29 distinct values. All right, so different values that has a mean of 40 and a median of 40. Okay, the new data set is created by adding 5 to each number that is greater than the median and subtracting 5 from each number that is less than the median. So let's first of all understand that there's 29 values. So just to get a visual on this, the 15th value, so if I divide by 2 and round up, the 15th value is the median. So you're going to have 14 values less than the median and 14 values greater than the median. So, and what I'm going to do is I'm adding, so basically I have the 15th value and I have 14 values here and I have 14 values here. And I'm adding 5 to each of these numbers and I'm subtracting 5 from each of these numbers. So clearly, if all the numbers that are greater than the middle go up and the other ones go down, the median itself is not going to change. So which does not remain the same? Well, median certainly remains the same. Now, if I think about how the mean works, is that's the sum of the values that are then divided by however many there are. Well, what happens is for every one of these that I add 5, I subtract 5 and they cancel out. So the sum is going to remain the same. So therefore, the sum remains the same, which then the mean remains the same. So the answer is a standard deviation because all the values to the right of the mean get bigger and all the values to the left of the mean get smaller. So it creates a larger spread or a larger variation. So standard deviation is a measure of spread. So the data is going to be much more spread out because all the values got further from the mean, but the mean itself didn't change. So it's definitely the standard deviation. Whoops. Jumped the gun there. We're down here at number 10. All right, so we've got a two-way table. So usually two-way tables, I don't really do much reading except for what it's asking for. So okay, so if a customer last Friday who purchased an item is selected at random, so then I would go back and double check. Yeah, this is the whole table. So the whole table is really, they're not narrowing it down to a row or column. They're saying a customer last Friday, which is the whole table, who purchased an item is selected at random. So I know it's out of 850. What is the close to the probability that the customer also used a discounted coupon? So that is just anybody in this column. So, oh, no, that's my bad. I read it wrong. All right. Let me restart that. So if a customer last Friday who purchased an item Purchased an item is here, so we're only looking at them. I thought the whole table was people who purchased item because I didn't read it as closely as I should have. So this is conditional probability. We only look at people who purchased an item. That's out of 576. Now, out of those, ignore everything else in the table. Out of those, what's close to the probability that they also used a discount? So use a discount is 62. So now, since they're decimals, I'm just going to do 62 divided by 576, and I get 0.11. All right, so you got to be really careful with these. Like I thought I was reading carefully and still missed it. So just look at if it's conditional probability. The word given gives it away, but they don't use that word. They don't always have to use the word given. If you see the word given, then you know it's conditional probability. But here we don't. They don't use the word given, so you got to be very, very careful. All right. So they did mention one of the headings in the row or column, so that means we're narrowing it down to just in this case that row. All right, now on to number 11. So we have a trig problem. So PR is 39, XQ, so we got 12. This is 39. What is the length of XY? And we also know what the tangent of P is. So I'm just thinking here. I have a way of doing it. I just don't know if it's the fastest. So I'm trying to think if there's like any kind of shortcut. Hmm. All right, so we're looking for the length of XY, so I'll call that X. The problem is, so my thinking is here, like I'm trying to just use this, but I can't because the tangent of it is 5 over 12, but I don't know either one. So I won't really know like the ratio. So I kind of have to include the bigger triangle. So, hmm. Okay. So I think I see it. So I'm going to look at the bigger triangle, and I'm going to realize that if I'm going to write a different color here. So these are the ratios, not the actual side lengths. So if the tangent is 5 over 12, I'm going to put 5 here and 12 here to represent the full length. But again, they're obviously not the lengths because this part is 12. They're the ratio. But what I know I have is a 5, 12, 13 triangle. Okay. This is why I really wanted to think about this for a second. So, um, what this means, right? 5, 12. Hopefully, we know 3, 4, 5s and 5, 12, 13s. All right. But this is a 5, 12, 13 triangle. And since this is 39, it means the big triangle is getting multiplied by 3. So that tells me this whole length is 15. And then if I multiply by 3, it tells me this whole length is 36, of which this part is 24. All right. So again, I have a 5, 12, 13 because the tan of P is 5 over 12. Then they get multiplied by 3 because this side is 39. Then this has to be 15. This whole side is 36. So this part's 12, or sorry, this part's 24. Now, if the tan of P is 5 over 12, then 5 over 12 is equal to this smaller triangle is also 5 to 12, right? Because it's still the tan of P. And that's X over 24. And X is what we're looking for. So X is, you can see I'm multiplying by 2. So X is just 10. All right. So I really wanted to think about it. I had another way of looking at it that would have definitely been a lot of extra work. So look for 5, 12, 13s and 3, 4, 5s. They will be extremely helpful in a problem like this. All right. We have a circle problem. So I think we could do this in Desmos, but I'm not. I'm going to do it the completing the square way and then show you a shortcut to that kind of. So the completing the square way is this. Oh, let me review real quick. The standard form of a square is x minus h squared plus y minus k squared equals r squared. And what I'm going to do is I'm going to complete the square to get these perfect squares. So I group the x's together, and I'm going to take half of -6 and square it and get 9. And then I'm going to take half of 8 and square it and get 16, and then add those numbers to the other side to make sure I keep everything balanced. I'm doing the full problem here, and then I'll explain the shortcut. Then I do x minus 3 squared is this perfect square. And here I do y plus 4 squared is that perfect square. And then over on this side, I get 81. And then that 81 represents the r squared. And also, the area of a circle is pi r squared. Well, if r squared is 81, then I have 81 pi is the area. So the way that I just did it, Desmos would probably be faster. You just throw it into Desmos and you look at the high point and low point. You'll be able to figure out the diameter and then divide it by 2 to get the radius, and you'll get 9 and then 81 pi. But to offer like a shortcut, given that we only want the area, we only want to know what ends up over here. I don't actually have to do this the way I should, right, in school or mathematically. I'm going to take a shortcut. And you can't really do the shortcut until you really like master this. Is what you need to do is just figure out the only way this side is going to change is if you figure out what two values you're adding to it. So I'm just taking half of 6 squared, I'm adding 9, half of 4 squared, I'm adding 16. So again, this side is going to change mathematically, but if I only care about what happens on the right side, I'll get the 81, and then I'll know that it's 81 pi. All right, so if you can get to that level, then you can bypass Desmos kind of being the faster way. But you have to start by really understanding the school way to do it, for lack of a better word, the real true mathematical way to do it, to then be able to say, okay, now I'm so good at that, I can just focus on which side I care about, whether it's the left side if they ask about the center of the circle, or the right side, which they ask for we need the radius or radius squared to get area. So that's really the level you want to try to get at, where you can just do the problem this way, almost in your head, and just get the answer and really, really save time. Okay, thank you for joining us as always, or watching on YouTube. Make sure you check out our TikTok or YouTube for all the other videos. We offer tutoring, and we have 8-week prep courses leading up to every SAT. We also have an daily SAT challenge. So, inquire about anything like that. We have a lot of free stuff as well as stuff that's paid. So thanks again.